Okay, this is the good moment again when we are going to have a discussion about digital electronics. And I would like to take this opportunity to welcome all the physical students and online students into this very interesting program when we are going to learn a new topic that's called the Boolean laws and the Boolean's laws, Boolean's algebra laws. My name is Olenjolai. It's the first time to meet me. I will be teaching you, and also I thank God by His own grace that to be your teacher or to be a teacher and also to be an engineer. We are going to discuss very important information with the context of digital electronics. So I ask you to have a fresh mind. This is the theoretical concept, but later on we'll be having some simulations and even practical verifications of this concept. So I think that you are well prepared, and I don't want to waste much of your time. Let us go to the class, but we have some physical students who are in this class. I would like to appreciate their presence, and then we start the class. How are you, students? How are you, mechanical engineering students? Good. Are you ready for lecture 1 of Introductions of Boolean's Algebra Law? Yes. Good. So there's no need of quick review because it's the new topic. So let us go directly into some important terminology. The first terminology that we want to understand is the terminology that we call it Boolean algebra. Class say Boolean algebra law. Boolean algebra. Say it loudly. Say Boolean algebra law. Say Boolean algebra laws. So plural. Boolean's algebra laws. Say it again. Where is Harriet? So whenever you pronounce that Boolean's algebra laws, you are writing in your subconscious mind. So the first terminology that we have to discuss is Boolean algebra. And then we'll be discussing some important terminologies in order to grasp the concept before you go for the Boolean's algebra laws. So we have a very important question. This is question 1. What is Boolean algebra? You can ask your neighbor because this is the concept you have covered in advanced electronics science. It's the first part, digital electronics. So he said that in digital electronics, and the mathematics, in digital electronics and mathematics, we define this terminology that the Boolean first, this is the names of the physicists, the Boolean algebra, we say that this is the branch of algebra. This is the branch of algebra. It's a branch of algebra in which variables, the variable values are the truth values. Are the truth what? Values. Which means true and false. True and false. Ordinary donated as, say that, ordinary donated as 1 and 0 respectively. These are the simple definitions of Boolean algebra. Before we discuss about Boolean algebra law, we have to understand first, because the word Boolean algebra, it's a vocabulary for the beginners. Are we together? Are we together? Yes. First of all, the word Boolean, this is the name of the physicists who have introduced or discovered the concepts of what? Binary, or the concepts of binary number, or the concepts of Boolean algebra. So this is the physicist. He has been the fancy, it means the first name is George Boole. Okay? George Boolean. So this is the physicist, French physicists who have introduced the concepts of Boolean algebra. So that's the meanings of the word Boolean. So Boolean, simply, it's a name of the founder of the concepts of Boolean algebra. Are we together? Yes. So with this context, a serious engineering student, we know that we had a word called the algebra, or algebra. It has been a topic that we learned in basic mathematics or additional mathematics, and also we learned in additional mathematics, in advanced pure mathematics, but also we learned it in basic engineering mathematics in ordinary diploma. So simply, in algebra, we have two branches. The first one, we call it linear algebra. Linear algebra. And also the second branch, we call it Boolean algebra. So linear algebra, it's the one that you use to learn about simultaneous equation. You use to learn about quadratic equation, right? You use to learn about polynomial functions. Those are the linear algebra. That's the branch of linear algebra. So you are very good about maybe how you can find binomials, polynomials, right? And how you can use the concepts of combination. That to say maybe n combination r, then we say that p power n and q power r. We means that that's the binomial conditions in terms of probability. So that's all about linear algebra. So the physical students that I have in this class, you are very good in linear algebra. But maybe you have just the foundations about Boolean algebra. Are we together? Yes. Why should we learn Boolean algebra? So we say that Boolean algebra. Why should we learn Boolean algebra in digital electronics? Boolean algebra is used to analyze. It's used to analyze and simplify. Analyze and simplify. Analyze and simplify different digital electronics, circuits, or this is used to simplify different digital logic gates sort of expression. So this concept of Boolean algebra is very important to be covered, because once you understand, you may use Boolean algebra or the concept of Boolean algebra to analyze. To analyze different electronic circuits or digital logic gates expressions. Or you may use the concepts of Boolean algebra to simplify. To simplify. You know that Tanzanians, we like simple life. Ask your neighbor. Do you like difficult life or simple life? Ask your neighbor.
Do you like difficult life or simple life?
And then listen the response. So usual, his response, his or her response is simple life. We like simple life. Why? It's by default. There's no disturbance. So, because you like simple life, good. It's better also for you to like Boolean algebra because you'll simplify your life. Are we together? When we say analysis, remember that simply in engineering field, including the mother of engineering, which I said is mechanical engineering, or maybe in electronics engineering, we have 3 things or 4 things. The first thing we used to do a lot of design. Say design. So design, this is actual, we say, it's a process of, first of all, identifying a problem until you get the final solution, which in terms of engineering, we call it a final product. For instance, we learned 7 steps of solving any scientific problem. Remember that I told you engineering is a purposeful use of science. So what we have been learning in physics, science, and mathematics, we have to apply to understand the engineering concepts. Right? Right? So design, for instance, that you say you have to identify the problem. Then, in case of science, you have to do hypothesis formulation. That's the second step. But in case of engineering, we have to say that once you identify the problem, you have proposed the solution. The third step, in case of 7 steps of solving a scientific problem, we say what we call experimentation. So in case of electronics, the 30 steps, once you have proposed the proposed solution, you have to present your solutions in terms of diagram. So the 30 step, we say that draw the general block diagrams of your proposed solution. The first step, we say that draw the detailed block diagrams of your proposed solution. And then the fifth step, we say that now design. Design, and once you design, you'll come up with a schematic circuit diagram. So in engineering, whether in mechanical, whether in electronics, whether in telecommunication, one of the responsibility, and this is called the primary responsibility of an engineer, to design. So ask your neighbor, can you design now? You call yourself an engineer. Can you design? Ask your neighbor. Ask your neighbor. It's a very ask and keep the response. If the answer is yes, tell him or her tomorrow bring to me your design. One of your design. The second, once we do the design, then we have again to do something called implementation. Say implementation. Say implementation. So implementation is actually implementing what you have thought and actually what you have presented in engineering. So when you say implementation, this is in simulation and the hardware implementation. And that's the primary function of any technician. So the technicians has to receive the complete design from the engineer in order to implement or to build. And the final products has to execute or has to work as the prior designs of the engineer. Are we together? Then the second responsibility, well, you can your neighbor could say that I don't know how to design, I haven't designed, I haven't implemented anything. Well, we say that also you have another area. So this is all. So it means we can have a final product. But remember that any final product may fail to work due to the different reason. So for that case, we say that in an engineering field, we have something called troubleshooting. Say troubleshooting. Troubleshooting. And then once you have the troubleshooting, also you have something called analysis. Say analysis. Why did I mention these 4 important jobs of any engineer or technician? Because I want to tell you where you're going to use the Boolean algebra to analyze the digital electronic circuits. So analysis and troubleshooting, what are you going to troubleshooting? they finish the design the product which is not working or which is malfunctioning. Then what is analysis? You analyze what has been designed. For instance, you have a mobile phone. Take your mobile phone. Take your mobile phone. Take your mobile phone. When the screens, the displays of your mobile phone fail, what do? You send to the mobile technician. Isn't it? Is that mobile technician design the new mobile phone or just do the maintenance and just do the repair? Just do the repair. So maybe he doesn't know how to design. That's fine. But he could know how to analyze, how to study all the process which have been followed to design. So similarly, in case of electronics, digital electronics, you can have maybe a digital electronic circuit. For instance, you can have a digital electronic circuit which consists of the following logic gates. And then maybe you have another logic gates at this point. And then you have another logic gates at this point. So this is A, this is B, this is C, this is what he say that this is C, and then you have that these three inputs, maybe you feed them into the NAND gate. So this is a schematic circuit diagram of the certain design. So you may use Boolean algebra. You may use the Boolean algebra to analyze this design. It has been designed by somebody, but you may use Boolean algebra to analyze. But also, you may simplify this schematic circuit diagram. You may redraw the simplified schematic circuit diagram by using few number of logic gates. But once you simplify, class, are we together? We are going to discuss those, so you should not worry about examples and how are you going to use them. I'm just building the concept in your mind. Is it clear? Yes. Okay. The concept of Boolean algebra, is also known as, so it has some other names, binary algebra. Say binary algebra. Class, say binary algebra. Say binary algebra. Then also we can call it logical algebra. So you can call it Boolean algebra or binary algebra or logical algebra. 1, 2, 3, let us go. Say Boolean algebra. Binary algebra.
Logical algebra.
It's just Sophia who is pronouncing, Edgar is not pronouncing. It has been a fundamental. So this has been a fundamental concept in the development of digital electronics. Digital electronics. And the computer programming language. So this concept, it's a fundamental. Boolean algebra or logical algebra or binary algebra, it's a fundamental concept in development of digital electronics. Say digital electronics. Say digital electronics. And also developments of computer programming language. Say computer programming language. Which computer programming language do you know? Ask your neighbor. Which one do you know? C++. C, you know Java. You know every programming language. You know MATLAB. You know or just you heard? So you can write just a program. Can you write a program right now? Huh? Okay, so I think that the concept I've introduced about Boolean algebra is clear. Now let us move into the second vocabulary. This is called the Boolean expression. Say Boolean expression. Say Boolean expression. So what is it? This is the vocabulary for some of the students. So Boolean expression is a logical stop murmuring is a logical statement that results the Boolean values. A is a true or high or 1 or false or low or 0. This is the simple definition of Boolean algebra, of Boolean expression. Class, say Boolean expression. Say Boolean expression. I will teach you the concepts of Boolean algebra by using the concept of linear algebra that you are familiar with. So you say that this is the logical statement. Say logical statement. Between men and women, who are logical? According to creation. Between men and the women. If you know men and you know women. Between men and the women, who are logical by creation? Men. Very good. Others, they don't have any idea. Why? Because you've been living single. So you don't know the other side. Well, and women by creation, they are emotional. Boolean. And God actually balances the equation. Because logical thinking provides responses after a long time. Emotion thinking provides responses immediately. You see how the equation has been balanced? So emotion provides solutions or provide the response within a short time. Logical can take a number of days. The man still telling that I'm still thinking about it. Okay, so some of students have understood what I'm saying. But emotional, just you hear that, okay, now you know that, hey, just the owner of the house came, tell us that you are, then you say, wait a moment, wait. We have to leave. Yes, hey. Okay, so I've just given that simple example because of logical statement. First of all, men are logical by creation. It's God who made them to be like that. They didn't ask you for. Women, they are emotional according to the creation. They did not ask you for. And everything has been created for good. It depends how you interpret it and use it. So everything is good. And that's why that once God has finished to create, he said that everything is good. For you, you say you comment God. It means you correct, this is bad. Are you sure? Where is yours? Okay, so he said that this is a logical statement that results the Boolean's values. Say Boolean's values. Boolean. So when you talk about the Boolean's values, just to clarify this concept, we just have only two Boolean's values. Boolean's values can be true, or can be high, or can be 1, or sometimes can be 5 volt. In that, or let's say that, just say, okay, for the symbol. And also the Boolean value is false, or can be low, or can be 0, or can be 0 volt. This is what we call Boolean values. So you have Boolean algebra, we have Boolean expression, we have Boolean values. Say it. Say Boolean algebra, Boolean expression, and Boolean values. So when you talk about the Boolean, stop writing. Refer what you have learned in linear algebra. Msaki has quitted the class, and I know. Refer linear algebra. In linear algebra, we can have an equation. We say that x plus 4 maybe is equal to y. Stop writing, I said. Then you can have another equation. We say that maybe we have 3 minus x is equal to y. You can solve it to find the value of x. Is it? But in case of linear algebra, x and y, this what we call them Boolean, we call them linear variables. Say linear variables. Say linear variables. Addition and subtraction, this we used to call them basic operation, or we call them operations. Are we together? 4 and 3, this we call them values or linear values. Okay? Later on, we'll have what? For instance, we'll have that. Stop writing, I say stop writing. Later on, we'll have the example of Boolean expression, which is A and B. Listen. So A, this we call it Boolean variable. B, we call it Boolean variable. And this one, we call it what? No, logical operator. Hey! You are chatting. No what? So A and B are Boolean variables. Say Boolean variables. This dot, the dot, this is what we call the logical operator. I will teach you soon. Yes, I'm trying to introduce to you, to actually to give you an just a sign that what we are going to discuss. Then A dot B together, this is what we call the Boolean expression. Is it clear or it's not clear? This one, x plus, but if you want to have a linear expression, the equal sign should not be there. Because an expression, it does not have the equal sign. So this one is what we call it a linear expression. Or you can have quadratic expression. Or you can have cubic expression. So that's what I told, because the concept of Boolean algebra, it's a new concept in your mind. I'll try my level best to use what you know in advance about linear algebra. Class, are we together? Yes. Are we together? Yes. So that's the meaning. So, and the Boolean values, for instance, for this case, we don't have Boolean value. But the Boolean values, we know that. It might be either true or false. That's what we expect here. We don't have any other Boolean values other than the two. Right? Right, class? Yes. That the means of what? Boolean what? Expression. Then, if that's the case, we have another vocabulary that's called the Boolean variable. Say Boolean variable. Say Boolean variable. Or Boolean variables. So what are the Boolean variables? So the Boolean variables, we say that are the variables. These are the variables. I will give you an example and I will show you which is Boolean expression, Boolean whatever I will show you. Should not worry. Okay, are the variables or symbols. Generally, an alphabet. Representing alphabet that represent the logical quantities or the logical values, such as 1 and 0. That's the meanings of 40 Boolean variables. Say Boolean variables. So Boolean variables, simply these are the letters we use to represent are either inputs and the outputs of our digital circuits. Then we have another important vocabulary, which is called before we learn about Boolean algebra laws, which are called the logical operators. Class A logical operators. Class A logical operators. Class A logical operators. What are the meanings of logical operators? Question 2, question 3, question 4. What is a logical operator? So you say that the logical operator or operators are the logical. So the logical operators are the logical gates or are the logical operation that represent the particular logic gate. That's the meaning of 40 logical operator. Class A logical operator. Again, say logical operator. I will give you examples. We have 4 logical operators in digital electronics and also in computer programming. In digital electronics and the computer programming language, there are 4 basic logical operators used logical operators. So remember that this logical operator, we use them in digital electronics, but also use them in computer programming languages. So in digital electronics and computer programming languages, especially high, even low-level machine language, high-level computer programming language, they have. There are 4 basic logical operators. So I will mention them based on where we use them. So let us discuss about logical operators used in digital electronics, and these are the logical operators that we are going to use in this module. So logical operators used in digital electronics. So how many logical operators do you have in digital electronics? Only 4. Stop writing. And remember that this logical operator, they represent a particular what? Logic gate, right? How many gates do we have? 7 logic gates. How many basic logic gates do we have? 3. Mention them. AND gate, NOT gate, and the OR gate. How many universal gates do you have? Mention them. NAND gate and NOR gate. How many types of exclusive gates do you have? 2. The first one is what? Exclusive OR gate and exclusive NOR gate. So 3 basic logic gate plus 2 universal logic gate plus 2 exclusive logic gate make how many logic gates? 7 what? 7 what? So it's actual complete the song that for we who have been studying some years ago, we used to sing it when we ran in the morning, and we call it in Tanzania mchaka mchaka. For the nowadays teenagers, they are not even running mchaka mchaka. But for us who have been studying 1990 and others who have been studying 1980, we used to run mchaka mchaka every morning, right? And sometimes 7 kilometers from the school. And whenever we run, we have to sing. And one song that I remember, how many days in the week? 7 days, 7 days, 7 days. That's the chorus. You don't know. Take the material. How many days in the week? So that song actually was teaching you about the number of logic gates in electronics. So you see that you will never forget it. How many days do you have in the week? 7 days. Sunday to Saturday. Sunday to Monday. Sunday to Saturday. Okay. Sunday to Sunday. Okay. Whatever the case, but you have understood the concept. Okay. So simply we have only 4. So we don't have 7 logical operators. Edgar, we don't have 7 logical operators. We just have only 4 logical operators. So listen. The first is simple logical operator is actually present the simplest gate, which is called what? So NOT gate, in case of the digital electronics, we represent by using this its operator, represents or represented by what? So NOT gate, we are going to use bar, which is negation or complement. Right? So what do you say that about bar? It means that here we'll have a Boolean variable. Right? So you say that we are going to have a bar on top of what? Boolean what? Variable. Then the second logic operator used in digital electronics is AND gate. How do we represent AND gate? So AND gate represented by using dot. This is AND gate. Okay? So that dot will be between the 2 Boolean variables. It's just like here. This is the AND gate. Okay? Number 3, ask your neighbor, are you happy with this material?
Are you happy with this material?
Don't wait the response. Then, OR gate represented by this logical operator, which is plus. So in digital electronics, that sign of plus is not a plus. That is OR gate. Say OR gate. OR gate. And that is not a full stop. That is AND gate. Okay. Then the first logical operator is exclusive OR. Exclusive OR. Let me just write because some of you don't know the symbol. Exclusive OR gate. So exclusive OR gate, it's a symbol used XOR. So this one is represented by plus, and then you have a small circle. That is exclusive OR. It's not OR. That's exclusive what? OR gate. Ask your neighbor, did you know this material?
Did you know this material, your neighbor?
What do you think that is if somebody call you that? Do you know something, my dear? That's showing a real appreciation. You have to reply it quickly. Because if you don't reply it quickly, then you'll encounter that. Do you know this, my enemy? So these are the 4 logical operators that we are going to use in digital electronics. Let us see examples, because through examples, you understand the concept. Hello? Hello? So the first example, you can find that a particular output of the Boolean algebra, it's a variable A and the variable B. So this is the example of Boolean expression. This is just the output is equal to that one. You may even just remove, just exclude this one and have A and B. Okay? So examples of Boolean expression. So for the case of expression, simply say that A and what? A and B. Then the second example can have A or B. The third example, we can have A or not get A. The fourth example, we can have B exclusive or C. The fifth example can have A and B or A and B and C and not and the complements of C. Then another example, so you can have A plus B or A or B or C, then and the B complement or C. Those are the examples of Boolean expression. And whenever you see that Boolean expression, you have to identify the number of logic gates. Class, are those examples enough for you? Yes. Let me clarify. Stop writing. Stop writing. Look. This is A and B. So here, hello, hello, hello. This is AND gate. So for this case, to represent this Boolean expression by using the schematic circuit diagram, we are going to have only one AND gate of 2 inputs. Are we together? Are we together, Richard? Then for this one, if you want to present it's a schematic circuit diagram or schematic circuit diagram, we are going, this is only one gate. We're going to have A or B. So it's OR gate with only 2 inputs. Do you see that how now you relate the previous concepts of logic gates and the Boolean expression? Then we are in example 4. Here we have only a single gate, which is not gate. We say single input because remember the minimum number of input, the minimum and maximum number of inputs in NOT gate is 1. Right? Right? We don't have a NOT gate with 2 inputs or 3 inputs. No. We just have other types of logic gates except NOT gate which have 2 or 3 inputs. Is it clear? Is it clear? Then here, this is the point. So this one is exclusive OR gate operator. Right? So this is A exclusive OR C. We have only single gate. Okay? Okay? Then this is the point. No. Who said no? Okay. This one, if you represent its schematic circuit diagram, is this one. A, B. This is AND gate. And this is out. For this case, if you represent it, this is or A or B. A or B. And here we have output. For this one, if you want to present this there, NOT gate. So this is A and this is out. Are we together, class? The schematic symbol of exclusive OR gate is this one. It looks like the schematic symbol of OR gate, but it's different. Hello, my friend? I'm trying to help you to understand. So for this case, this is B, this is C, this is out, or output. Class, are we together? Are we together? This is the schematic symbol of what? Exclusive OR gate. Are we together? Then we are in example 5. For example 5, we have AND gate here. Say AND gate. So that's the first gate, agape. Then we have OR gate. Say OR gate. That's the second logic gate. For this case, we have 2 gates. The first one, it's AND gate with 3 input, which have a Boolean values A, B, and C. Are we together? Yes, are we together? Yes. Are we together? Yes. And also we have another NOT gate. But this NOT gate is connected at the input of what? Of C. So, in a simple language, how many logic gates do you have here? 1 with 2 input, 2, right? 3 with 3 input, 4. Hello? Are you there? He was not there. My friend has been home. He went to home. His mind was home. Remember the human responsibilities at home. All of us, we have responsibilities, but we left them at the entrance door. Once we finish the class, everyone is going to be covered with home responsibilities and go and resolve family problems, which will never end. Family or marriage problems, if you want them to end, just die. We'll solve one and then erase the other one. I'm telling you because I'm in that industry. So, and there's expected problems and unexpected problems. You may sleep with comfortable environment and the next morning there is a crash and a critical crash. You get surprised. Are we the same people who slept here yesterday or different? Okay, I'm sharing the experience, okay? How many logic gates do you have here? 4. Let me repeat for my friend who has been out in mindset, but I brought him back, right? Yeah. Yes. Human beings is busy. This is the first AND gate. And this is what? Second, which you call what? OR gate. And this one and this one is what? The third logic gate. So we call it what? AND gate. And this one represents what? not gate. So we have 4 what? 4 what? Logic gates. And these are the basic logic gates. AND gate, OR gate, AND gate, not gate. Class, are we together?
Yes, sir.
Thank you very much. Then this is the point where we are. This is A or B or C. How many gates do we have in this?
1 gate.
1 or 2?
1.
My friend here, how many gates do we have in the first bracket? You are still counting? 1. Tell us why it is 1. Oh, because it is 1.
3 inputs.
Aha. So it is 1 OR gate with 3 what? Inputs. Input A, B, and D? C. Are we together?
Yes,
Are we together?
Yes,
Then this is what? This is the gate? This is AND gate. But it's called what? Logic key?
yes.
Logic key project? Logic operator. It's called what?
Logic operator.
Eh?
Logic operator.
Eh?
Logic operator.
It's called what?
Logic operator.
Say logic operator.
Logic operator.
Eh? And then this one represents what? Hello, hello. She has gone out again. Are you back?
Yes.
Yeah, she's back. This is what? Not what? Eh? And this one? Oh, gate. So how many gates do you have there? Tell your neighbor. There we have 3 or 1 or 3. Tell your neighbor. It's time to talk with your neighbor. Tell your neighbor, don't tell me. Don't tell me. Tell your neighbor. What the conclusion? My friend, you are not saying anything. So you have 4 logic key. Yes, clap your hand yourself. I think that you understand. Clap your hand. And even those who are not speaking. Okay. So where the first gate? Where the first logic gate? A. This one, A. How many inputs? 3 input. What the second logic gate? This one. Right? How many inputs? Are you sure? 2. Very good. Clap your hand. You are right. So you, that one friend was sharing. It's 2 because the inputs of these AND gates are 2. The first one is this one. The second one is this one. Okay, as I say yes or whatever. I think that we draw this for you to understand. Then this is the second one, right? Richard, where the said gate? This one. What the name? Richard has forgotten. What the names of that gate? In B? What the names of this gate? All of the students. Naughty gate. And then you have also what? OR gate. But this is OR gate with how many input? With how many input? A? 2 what? Input. This is OR gate with how many input? You may use 3 or you may use 2. Depends. But it's better to use 3. So how many gates do you have in total? 4, A? 4 logic gates. So now let us link this concept with the previous concept. How do we link? Let us draw the schematic circuit diagrams of this Boolean expression. Right? Let us go together. Stop writing. So schematic circuit diagram. We have what? The first gate is what? A? AND gate. We say how many input? Input A and input what? B. This one. Okay? Then tells it is output. So we should wait. Then we have another combination. A and B and what? And C. Aha, so you may use the AND gate with 3 what? Input. The first one is A. The second one is input what? B. Right? A. Then the third one is C. Then we have the AND gate with 3 input, just like this. Yes. Fine. So we have also NOT gate in C. That's good. So we have our NOT gate according to what you have said. This is C. And then, so do you see how you draw? So whenever you see the OR gate or the AND gate or you see the bracket, hello, hello, hello there. Whenever you see the bracket, or it's not, sometimes you may introduce the brackets yourself. But you have to make sure that you draw the logic expressions, which is actual, the single one. And then we'll be combining. So this, for instance, this OR operator or logic operator is combining the output of this and the output of this. Are we together? Be careful. Because you may just draw plus, 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 or, and a lot of them, and then you get confused. Separating, look here. This one, it's independent input. And this one is independent input. So we have A and B. This is the single logic gate. Then the output of this gate will be OR with outputs of this combination. But here we have NOT gate first. That's why we have NOT gate. Okay? And then NOT gate C and B and A. That's why we have this one. Then the output of this logical combination is OR with output of this one. So for that case, we are going to have this combination. So you are going to have what? OR gate. OR gate. So this is our schematic circuit diagrams representing this Boolean expression. Is it clear? We used to test the students that to give the Boolean expressions and draw the schematic circuit diagram. Or to give the schematic circuit diagrams and then deduce the Boolean expression. That's why we are teaching you this concept. Are we together? Yes. Okay. So can you try for this? Try and then show your neighbor. Try to draw this one and show your neighbor. Just try on the rough paper and show your neighbor too, and your neighbor will mark for you. I told you whenever you come to my classes, choose a good neighbor. Choose a good what? Neighbor. Because you may be right in your trying and then your neighbor put X that you have missed it. Hurry up. Are you done? Quickly, you just draw. You have the response. Follow you get. Okay. So let us do correction. The schematic circuit diagram of 40 of example 6. So let us go together because you tried, and let us analyze whether you are right or you made a mistake. Edgar, it's not the time for discussion. Where should we start? To draw the OR gate with 3 what? Input. That's the starting point. First input, second input, third input. Here it's OR gate. This is A, this is B, this is C. If your neighbor is drawing that, put a tick to encourage your neighbor. Hey, it's a hard work. Your neighbor didn't know that before coming for this class. It's a hard work. You have to honor it. Then the second drawing is this one where you have 2 gates. NOT gate and the OR. So remember that we don't, hey student, listen. Listen, stop writing. It doesn't mean that because you have A, B, C, B, C, we'll have a lot of A, B, C. No, 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 no. If just you have 3 inputs, then we'll be using and interconnecting them. What I mean, it means that it's not allowed for you to draw that. This is maybe another B, this is another C. And then maybe you have what? The OR gate. No, this is not correct. This is not allowed. We have already B, we have already C. Why do you have 2B and 2C? We have to tape them from here. Are we together? Yes, because I know some students can do that mistake. And especially your neighbor, I think that he or she has done that. Okay, it's a secret. He had a lot of B and C. Okay, so then, we have what? B. Then the B, it has not gate. Then we have what? C. So B complement or what? Or C, isn't it? So if your neighbor has drawn the not gate in this fashion, put a tick for that not gate. So you see that your neighbor is going to get excellent, He's about to get excellent. Then, if your neighbor is drawing the second or the third OR gate or the second OR gate, put a tick to encourage. This is the difficult business. After having this, stop murmuring, stop quiet, wait, keep quiet. So this one and this one, then you have what? And. So the output of A or B or C is AND with output of what? B complement or C. Right? Then you have what? AND gate. Then this is output. So if your neighbor has drawn the first logic gate, put a tick. And then once you finish, put a big tick. And then write 4 out of 4. Excellent. Because your neighbor has been enjoying 0, 1 out of 20, 2. So write that to encourage and keep the history. Because you might find that in the class, the first students have scored 25 out of 15. And the others, you find that they are around 2 or 1. And it's normal for the test. For instance, for myself, I remember that one of the tests I did, it was satellite. The first student scored 2 out of 20. And myself, I scored 0 out of 20. So I was number 3. And we are almost 80 students. So you should not be confused by scoring 0, 1, 2, 3. It's just a part of life. It's just a part of who? At the end of the game, you will make it. Tell your neighbor, don't worry, you will make it. Tell your neighbor, you will make it in Pangonusu. So please let us label our schematic. A. Keep quiet. Figure 1. The schematic circuit diagram of example 5. And this one also. How about your neighbor? Did your neighbor perform well? Yes. Tell him or her, congratulations. You choose the good neighbor. You chose the good neighbor. Okay? Is it clear? Yes, so let us end our lecture 1 by just introducing to you the logic operator that we are using in computer programming language. So in the next lecture, which will be lecture 2, I will teach you 8 Boolean algebra laws that we are using in digital electronics. So get prepared and you have to make sure that you don't miss it. Logical operators that are used in. Why is your neighbor talking? Computer. Do you know why? Because your neighbor say, I have understood the concept. Computer programming languages. Logical operators that are used in computer programming languages. We said how many logical operators do you have that you are using in computer programming language? We said also you have 4. You said you know C++, yeah? C#, C plain, MATLAB, Java. You know so many programming languages, but you are using none of them. So one of the topics in any computer programming language is about Boolean logic operators, or yes, about Boolean algebra. So we say that in case of computer programming language, say computer programming language. Example C or C++ or Java or MATLAB or C#, etc., etc., etc. So there we have Boolean operator. Tell your neighbor, be happy, please. Tell your neighbor, be happy. So notigate. Hey. Notigate represented by, in case of computer programming language, notigate is not represented by complement. Notigate is represented by a letter that we call either naughty, or in some of the computer programming languages they are using not in capital letter. Remember that in any programming language, or most of the programming language, we call them, they are case sensitive. Say case sensitive. If, for instance, you define a variable by using a capital letter, and when you come and call that variable by using small letter or lowercase letters, you know that the compiler will identify error. You know meanings of case sensitive? Case sensitive in programming language, we say that A is not equal to R. So uppercase A is not equal to lowercase a. If case sensitive. If case insensitive, upper capital A is equal to A, lowercase a. Are we together? Yes. So some of the programming languages, they are using notigate by using not of the lowercase, and some of them they are using not of the upper, and some of them they are using this symbol. Okay? Also in computer programming, we have also AND operator. Say AND operator. Say AND operator. So AND operator will be performing the same function of AND gate. This one in programming language is presented as what? Represented as AND with capital letter, or AND is lowercase. So these are the operators. These are the operators. Then the first logic operator is OR gate. Okay? So OR gate, this is represented by what? Or as capital letter, in some of the computer programming languages, or as a lowercase. Are we together? Are we together? Number 4. We have what? Exclusive what? OR gate. This in short we call it what? X what? A? So this one in computer language is represented by this symbol. And then here we have Boolean variable. Are we together, class? Yes. So let me give you examples. How do you write statement there? I'll just spend a few minutes, then I'll release you. I know that it's your time to sing the song. Sa, 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 sa. Childhood age. It was very interesting, no stress. But now, when you leave this place, you will encounter your stresses outside there. They are waiting you. They are saying, hello, John. How are you? We have been waiting you to give a cab back to home or to work. Examples of logical operators of computer programming language. During your childhood, now you have already slept, yeah? At this time, eh? During your childhood, now you are in the middle of sleeping. Eh? Shower, eh? Okay. So a simple example, stop writing. A simple example in the logical operator, we can have that. Let's say that this is input 1, not input 2. Then we can have a statement that we say that in case of electronics or mechanics, can have sensor 1 and the sensor 2. So this is AND operator, sensor 2. Are we together? Then we can have, again we say that, we can say that we have to have sensor 1 and then sensor 2. Then in case of the, we can have condition, maybe condition 1. Then condition 1. Then we say that, or condition 2 and the condition 3. Can have a statement like that. Or sometimes if you late the variables to be laters, for instance that you're using later, let's say that variable A, then you say that exclusive B. We can have again another example. Let's say you can have A, then we have or B. If you are using this as your variable in computer programming language. Are we together? Yes. Yeah. So let's say that this is the end of lecture 1. First of all, did you understand? Yes. Did you understand? Yes. It's time to appreciate you. I always appreciate any students who understood the class or understood the lecture. So now prepare your hands to reduce stress. The aim is just to reduce stress. We have been surrounded by stress everywhere. Right? In our marriage, in our family, in our working, at the school, including the IT. 1, 2, 3. Ongera. Imara. Wow. So we sing the chorus. Sa, 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 sa. Sasa, sasa, saya kwenda kwetu. Kwaheri mwalimu, kwaheri mwalimu, tutaonana kesho. Thank you very much. Be blessed. See you in the next lecture. you.